In this example, we've been asked to differentiate the following functions with respect to the variable given in the question. Let's have a look at the first question. We have g of t is equal to 2t squared minus 5t plus 2. So we can see here our variable is t and our function is g of t, or g. So we're going to have to find, for the first question, dg by dt. So that tells us that we need to differentiate each term with respect to t. So we're going to have d by dt of 2t squared plus d by dt of minus 5t plus d by dt of 2. So let's recall some general results. If we want to differentiate some power of t, so t to the n, we bring the power down the front and take 1 off the power. If we want to differentiate a constant with respect to t, well, we get 0. So using these two results, we should be able to find dg by dt. So we need to differentiate 2t squared, but the first thing I'm going to do is bring the 2 out the front of the derivative. So that will leave us with 2 lots of d by dt of t squared. And for the next term, I'll bring the minus 5 out the front. So I'll have minus 5 d by dt of t. And then we have d by dt of 2. So differentiating that constant 2. So let's use these results that we've just written down. We have 2 lots of the derivative of t squared. So what does that tell us to do? Bring the power down the front, take 1 off the power. So that will give us a 2t. Then we have minus 5 lots of the derivative of t. Well, let's think about t for a second. T on its own is just t to the power of 1. So if I want to differentiate that, recall the rule, take the power down the front, so that would be 1 times t to the power of, take 1 off the power, so 1 minus 1 is 0. So I end up with 1 times t to the 0, and anything to the power of 0 is 1. So I end up with 1 times 1, which is just 1. So the derivative of t with respect to itself is 1. So coming back to our question, we've got minus 5 times 1. And then we have the derivative of 2 and the derivative of 2. Well, 2 is a constant, so we just get 0. So we can write down our answer now. dg by dt is 2 lots of 2t, so that is going to give us 4t. And minus 5 times 1 is just minus 5, and we don't include the 0. So our answer, dg by dt, is equal to 4t minus 5. Now let's have a look at this second example. We have h of theta is equal to cos of 2 theta, and then we have plus e to the 2 theta. So for this example, we're going to be differentiating with respect to theta. So we'll write dh by d theta is equal to d by d theta of cos of 2 theta plus d by d theta of e to the 2 theta. So again, we should write down some rules to help us differentiate these two functions. So starting off with the cos 2 theta. Okay, we notice it's of the form d by d theta of cos a times theta, where a is some constant. And we should recall that to differentiate this, we get minus a sine of a theta. Looking at the next one, to differentiate e to the 2 theta, well, that's of the form e to the a theta. Now recall in both of these two examples, a is just some constant. So it could be 2, it could be 3, it could be minus 5, but it's a constant. And we should recall that to differentiate e to the a theta, that becomes a e to the a theta. So we can use these two results to find our dh by d theta. We have cos of 2 theta, so that will become minus 2 sine of 2 theta. And then the derivative of e to the 2 theta, well, what do we see? We just see the constant in front of our theta, or in front of our variable, just comes out to the front. So that will give us 2 e to the 2 theta. So that's our second part answered. We can see that dh by d theta is equal to minus 2 sine of 2 theta plus 2 e to the 2 theta.